Balancing equations. You're going to balance 20 chemical equations so that they have the same number of each element on each side of the arrow. So here are the reactants, here's the product. You have to make sure that you have the same number of each atom on both sides of this arrow. In other words, you can't magically gain or lose atoms. They have to be somewhere. You cannot, however, change subscripts. For example, see how on this one, on the left-hand side of the arrow, you have 1 Mg and 2 O's. On the right-hand side, you have 1 Mg and only 1 O. You cannot just add a 2 here to make this MgO2, because that compound doesn't exist, nor is it what's formed in the reaction. MgO is formed in the reaction. It's like if I said, hey, this is going to form H2O. Well, we know what H2O is. It's water. But if I said, oh, well, you know what, that equation doesn't balance, I'm going to add a 2 here. That's no longer water. And if the equation, if the reaction forms water, then it's going to be H2O, not H2O2 or any other combination of numbers. So what we can say though is maybe it makes more than one H2O. So maybe it makes 2 H2Os, and now I have those 2 O's I was looking for. Okay, I can have more than one molecule of water, but I can't change the structure of water. Let's get back to this. I'm going to show you 2 different ways to balance equations. Use whichever way works for you. So I'm going to go ahead and do the more traditional way using this first equation. So first we look at the number of each atom on each side. So I've got Mg and O, so I'm going to write those down, Mg and O, and I'm going to write down Mg and O on the other side. Even if these had been in a different order, I'd still write them in the same order that I wrote them on the left, just so I can compare across. How many Mg's do I have on each side, and how many O's? So I have 1 Mg and 2 O's on the left, and 1 and 1 for Mg and O on the right. I can see that my O's are not balanced, so what I need to do is put a coefficient here. Remember, our coefficients multiply, so I need to multiply by 2 to get the number that I need here. This doesn't just change O though, it also changes Mg. Now I have 2 Mg's and 2 O's, so I'm going to write that down. So I've fixed my O's, so I have 2 and 2, but now my Mg's aren't balanced. So I'm going to come over here to the left-hand side, and I need 2 Mg's, so I need to multiply this by 2, so I'm going to put my 2 in front of Mg. That changes Mg to 2. It does not change my number of O's. This plus sign separates Mg from O2, so 2 only affects Mg here. I would have to put a number here in front of O2 to change the number of O2s that I have. Now that I have 2 Mg's on each side and 2 O's on each side, it's balanced. I'd like you guys to get into the habit of writing a 1 in any blank that you leave. Now, this isn't necessary. If there's no number there, it's understood to be 1. However, on the tax test, they will look at what the coefficients are at the end and ask you what they are. They won't ask you what are the coefficients and give you an answer choice that is 2 blank 2. The answer choice would be 2, 1, 2. So make sure that you're used to writing those ones. Now let me show you another way to balance the same equation. So I had Mg plus O2 yields MgO. So I have Mg plus O2 yields MgO. Now in this method, what I'm going to do is show exactly how many atoms I have in each compound. So here's Mg, I only have 1 Mg, so right underneath it I'll write Mg. Here I have O2, which means I have 2 O's, so I'm actually going to write out 2 O's. And it gives me, I'm going to draw my line down from my arrow separating the reactants from the products, and I have 1 Mg and 1 O, so I just write 1 Mg and 1 O. Make sure you put all these, if you use this method, make sure they all go on one line when you write these out. So I didn't write my 2 O's one over the other, I wrote them next to each other. Now all I have to do is count. 1 Mg, 1 Mg. 2 O's, only 1 O. Well, that's not enough. What I can do is make copies underneath it. Now I can't just make a copy of the O, because that's not what's in our equation. MgO is in the equation, so I need to make a copy of MgO. What I just did, I just made 2 MgOs, okay? So now I have 2 O's on the left, 2 O's on the right. It's balanced. For Mg's though, it changed that. So I have 1 Mg compared to 2 Mg's, so I need more on this side. So I'm going to make another Mg here, and now it's balanced. 2 and 2, and then my oxygens are 2 and 2. To figure out what numbers to write in these blanks, I count how many rows of each compound I made. I made 2 rows of Mg, so I write down 2. Here I made 1 row of O2, and here I made 2 rows of MgO, so I put a 2. I got the same answer, 2, 1, 2, as I got here, 2, 1, 2, for the same equation, but I did it a very different way. Now whichever one works for you is the one you should use. Okay, so make sure that you've written down both of these if you're not sure which method you're going to use. Now I do want to also give you a little tip for some of these that get a bit harder that use polyatomic ions. For example, number 15. When you're balancing something with polyatomic ions, you're going to see them in parentheses typically. See, we've got phosphate here, PO4, and on the left-hand side of my arrow I also have PO4. So if you are balancing the equation where you write them all out, you can write K and then PO4 and Ca. Right, so I might write K and then PO4 and Ca, and do the same thing on the other side, K, PO4, and Ca. If I were doing it the more visual method that I showed you second, I could do it this way. Here's K, I have 1 K. Here I have 3 Cas and 2 PO4s, so I would write 3 Cas, right? 3 Cas, 1, 2, 3, and 2 PO4s. PO4, PO4. Okay? And that way you just have to count how many PO4s there are rather than separating out the P's and the O's. So if you have polyatomic ions on both sides and those elements are not anywhere else in your equation, you can use this method. If, however, you have a polyatomic ion and it's not the same way on the other side, for example, here's number 14, has SO4 in it, but there's no SO4 on the other side, so I cannot use that in this one. So I can't put SO4 as a polyatomic as a group and balance it that way because I don't have SO4 on the other side. Okay, so make sure you've got that polyatomic ion on both sides of the equation, and then you can balance it out just like you did the others. If you do still have any problems with balancing equations, make sure that you come ask.